So Jim is trying to figure out how the eye works to be able to see Pam the way he does every day.
So this is what the eye would look like on the inside of Jim's eye looking at Pam. So there's a lot of functions and structures that make the image understandable for the brain. So you've got a thin layer of mucus, which is the conjunctiva, which is the protective outer covering that covers the front of the eye. It's right there. Then you've got the cornea, which is a transparent layer of tissue that reflects light rays, and that's right there. And then you've got the anterior chamber, which has the aqueous humor in it. And then you've got the pupil, which is empty space, and then the iris, those two right there, which are made of muscle and contracts when it either dilates or constricts and responds directly to the light source. And then we got the lens, and this can change shape to what you're looking at due to the ciliary muscle. And the ciliary muscle is right there, that blue. It goes all the way around. And then there's the retina. And this is the lens refracts to bend in the retina and sees things upside down in the retina before they're changed to right side up, going through the optic nerve to the brain. And then the posterior chamber is right in here, and it's filled with vitreous humor, and the pink is the vitreous humor. And then there's the optic nerve, which has the central retinal artery and vein, which are those two lines right there. And the optic disc is right there, and that's like the blind spot of your eye. And then the macula, that dot right there, has a high concentration of cones. And then the sclera provides a protective layer, which is in the purple. And that's like all the functions and things of your eye. Now I'm going to tell you how the eye works and how it actually sees the image of Pam in Jim's eye. So first, the light passes through the cornea, and as it does, it's bent and refracted onto the lens right there. And as the light passes through the lens, it is bent for a second time, and it finally arrives in the retina where the image is formed. And the double bending has reversed the image, and it means that it's upside down. And the image has to be turned right side up in the brain. But before that, it needs to enter impulses along the optic nerve, right in there, into your brains in the occipital lobe. So now we're going to talk about lens accommodation. And this is when the optical power of the eye's curvature changes in order to focus on objects at a range of distances. So say that Pam is getting closer to Jim, then the curvature of the eye is going to change. And so the lens is flexible and has the curvature controlled by the ciliary muscles through the zonules, and the zonules are right there, and those are on the ciliary muscle that kind of change the shape of the lens. And when the ciliary muscles contract, the zonules loosen to a rounder shape in the shaped lens and a higher refractive power, which enables us to see at shorter focal distances. So like she's closer to you, then it becomes more round. And then when the ciliary muscles relax, the zonules increase in tension, creating a flattening of the lens, thus an increase in further focal distance. So it helps you it flattens when she gets farther away so that you can focus on how she looks. And that's what accommodation is, pretty much. So now we're going to take a deeper look at the retina, and the retina has the cones and rods inside of it, and the cones help us to see in bright light and things of color, so like during the daytime it helps us to see things better. And then the rods help us to see in dark or dim light, so like at nighttime. So this is the rod cell, the white one, and then a cone cell is like the blue one. And so impulses are transmitted to the bipolar cells. So they go through here to the bipolar cell, which stimulate ganglion cells. And the ganglion cells, so it goes here through a cone, and it goes through the bipolar cell to the ganglion cell down. And there are 3 types of cone cells, sensitive to red, green, and blue light, and they're not usually active in the dim light. And so like you can't see, that's why you see darker colors when it's darker out.
So now Jim knows the science behind how he sees the image of his wife Pam every single day.